Hi, this is Venkatesh Prabhu. I'm going to discuss about solving a chemical reaction using Berkeley model. So, Berkeley model software is an open source software. It is available at a free of cost. You can download and install in your laptop. Once you install, you can open the file. The file will be looks like this. In this, open the model. From the model, choose a chemical reaction. A window will be open. This we need to feed a conditions. For an example, a reactant as A and B is going to form a product of C with the reaction of reversible reaction. If its rate constant is 0.05 for a forward reaction, the rate constant for the reversible reaction is also 0.05. Then add this and we'll be getting this. The initial values are initial of A is going to be given as 100. Initial of B is given it as B as 80. So another reaction it is going to be formed as C further reduced to D but not in a reversible order. It is an irreversible reaction. So I have given the Kr value as 0 and Kf value is 0.35. For an example, I have given, then add these conditions. Here we need to use the value of C as C is going to be formed from A plus B. Then give OK. Then check the values. We'll be getting the results in this form. There are two differential equations which is formed. First reaction A undergoes A plus B undergoes C. Second reaction C undergoes D. The rate of formation of D is from C. So this is going to be formed inbuilt from the feed conditions. Here A and you can see the legend and the values of A, B, C. Initial values whatever we were fed at that is going to be given here and the A and B is going to be a reduced form. C increases, then further reduces. When C reduces, B is also going to be formed. So by this way, we can able to predict the results of through simulation with the help of the real model. And we could also find out the table. This table could also be called it as a predicted value. It can be compared with the experimental results. So with this we can able to simulate or we can able to change the differential time. Differential time is 0.01. We will check and how the reactions are there. So the number of data will be getting high because 0 to 10 minutes. What is the changes it is going to be? Either it is a minute or hour, whatever else. We can able to find out based on the difference. 0.01 is the differential values. So the number of data what we are expecting to be very high. Or suppose if I want as 0.01, then we will be getting thousands of data. Those thousands of data will be formed in this form of equations. The same way, I could also solve another reaction, a classical reaction, which is going to be used for um, chemical reaction, that is enzymatic reaction, Michaelis-Menten model. Let us check the Michaelis-Menten model. So go to the new documents, again open the model, go to the chemical reaction, feed the conditions as E plus S enzyme plus substrate, use enzyme substrate complex with the rate of the same value 0.05 to 0.05. I have given, then add the reaction, give the value of E as 10 and the value of S as 100, then go to the new reaction. Here PS undergoes product of P. So then this is not a reversible reaction. So feed the conditions as 0 for the reverse rate constant and Kf as 0.01. Then add this reaction also. So there are two reactions you have added. Here the product P is going to be produced from substrate as well as the enzyme. So once we fill these values, go to the conditions as OK, then run it, we'll be getting the results. So this is the way we can able to simulate enzymatic reactions or any chemical reactions which is in the form of a stoichiometric that could be given the initial conditions constant and it will form automatically the differential equation. With this we will get the tables. Thank you.